Lesson C5, Intermediate Calculations, Topic 7, Series Conditioning Functions. The learning objectives for this topic are to understand the different series conditioning functions, which are stepped, no-bad, time shift, and time shift dynamic. Now, the step function allows you to step each raw value forwards when interpolating. So rather than linearly interpolating between 2 points, you hold the value of one point until you come to the next point and then you step to that next point. Visually, it's possible to do this in Eigen trends without using this calculation. The reason that you use this calculation is to force a stepping behavior within another calculation for a tag. No bad will return a time series with all points with bad status omitted. Time shift allows you to shift the timestamp or stamps of a point or series by a fixed amount forwards or backwards in time. And time shift dynamic shifts the timestamps of a point or a series of points by a variable amount forwards or backwards in time. So the use cases for these are stepped is extremely useful when integrating daily values. So where you have a value that's the single total that represents the sum or the average of production across a day, then in the totalize you want to hold that value for the entire day. You don't want to linearly interpolate between that value and the next day. So when we totalize across these kind of values, we need to use the stepped function, wrap our tag in stepped. No bad is useful when you have data from sensors that may spike, e.g. 999 or minus something. But it only works when the OPC status is set to bad. And this does happen with some transmitters where they actually know that something's gone wrong. There's, say, been a voltage spike. So they report a value, but they attribute a bad status to it. And then time shift allows you to say correct for something like a time zone error in the source data. If it was set to GMT or it was recorded in Zulu time, but you know that you need to look at it in European time. And then time shift dynamic allows for things like shifting a lab value to exactly midnight when it has been entered at some variable point in time the next morning. So now let's look at these in detail. First of all, stepped. Let's say we have a forecast for the number of units that will be produced each day. And the series looks something like this. Now this could be days or months. We're going to just look at days for now. Now if we wanted to know the total number of units produced in this 4-day period, we would need to add them up like this. The value at midnight applies for the whole of the day. But if we were to leave it to the linear interpolation function, we would end up totalizing this, because the linear interpolation will just work out a line between each of the 2 points and draw a straight line and just add up the area under that. So we need to tell the totalize function that the value needs to be stepped and held until you find a new raw value. So that's a use case for the stepped function. Now let's look at a no bad situation. Here we have a set of data and one of the data points has a bad status. If we were to totalize these, it would look like this. The bad point would drive our total low because we've got a big negative or a negative number, and it will really skew the data. So if this sensor is known to be accurately reporting bad points, we can use the no bad function and totalize this area instead. And now let's look at the time shift function. So let's say we have a point entered at some point in day 2, but it actually applies to day 1. An example might be an end of day value that resets after midnight and or in the wrong time zone. We need to move it back a fixed amount. And because it's a computer generated value, it's reliable. The offset from when it should be is known, it's repeatable, and so we can apply a basic time shift to that data. That's what the time shift function allows. The dynamic time shift covers the use case where the value is not entered reliably at the same time or the same offset. And so we need to calculate a varying degree of offset. For example, a lab value entered at some point in the morning that applies to the previous day at midnight. So we want to time shift this value back to the previous or midnight, either on that day or at 23:59 or something. But it means that we can apply a variable offset to each point. So, okay, that covers the theory of the series conditioning functions, and we'll look at worked examples in the next sections of the lesson.